Okay, welcome back to our class. Today we are about to discuss about this quick sort. And up to now you have been looking into the sorting algorithms, which have been taking around big O of n, big O of n square, maybe. If you draw a small graph, n square is greater than n, and n is greater than the next one is log n log n, and the next one is log n. So there is a hierarchy like n square, n log n, and log n. Now, first of all, I want to discuss with you, right? Quicksort is really a quicksort. It is coming into the family of divide and conquer. Because of divide and conquer, you will have something called low complexity in solving the problems. For example, take the British India. Once Alexander came to India during 300 BC and he tried to invade India in a sequential manner. He wanted to conquer the North India initially, which is known to the known world. He started invading from Pakistan, present Pakistan. He came to Punjab. It took a lot of time and his soldiers were vexed off. Immediately Alexander has to change his plan of not invading India and go back. But British never done that mistake. British divided India into three major presidencies: the Madras Presidency, the Bombay Presidency, and the Kolkata Presidency, and later on to Delhi. When they have divided this into presidency, at a time the British army could occupy the nearby areas around those presidencies. This is how the British have applied a strategy of divide and conquer. Now, our sorting algorithm up to now we have been doing as sequential, and now we will do it in divide and conquer. So this is the one. The entire sorting will be divided, the entire array will be divided, and now each array, the divided array, will be again sorted. This is how we will do this particular one. Okay, let us see how you will divide it and what are the things that you will use to divide this particular one. So I will not disturb you again. I will only move these particular things and you just focus on looking at this particular array. Right. So I have prepared some algorithm which I will type it at the last. For that, I will first read out what are the steps that are needed individually. The first one will be input an array of unordered numbers. Okay, this is an array of unordered numbers which I have input here. Okay, the first one, the 0th element is 3, the first element is 7, the second element is 6, the third element is 8, the fourth element is 4, of course, the fifth element is 2, and the sixth element is 5. So there are 7 elements in your array. Next one is put the pivot at the last element. Now remember, pivot, I consider this one as pivot. That's why I have done a small diagram for that using P. The P with an arrow mark which indicates that it's a pivot. Pivot is considered as a boundary to divide our array into sub arrays. follow each and every sequence what I am telling to you. Now let us take this pivot. Initially we will say that this is the boundary for my array. So I keep the pivot at the last element. So put the pivot, the second point is put the pivot at the last element. Yes, you have done it. Right. Now start I from the first 0th element. So now you need to go for I to be started at the 0th element. Right. So this is our I. So what he says is that we need to start at the 0th element. Okay, we have kept it at 3, which is the 0th element. And the algorithm says that the I should be from the 0th element and go up to the pivot minus 1. Let us consider this pivot as P, alphabet P. So I will say it is P minus 1. The I should come up to only P minus 1 position. So the first step we have done is input an array of some unordered numbers, and I call this array as A, and I said that put the pivot at the last element. Fine. Next, the third point is start I with the 0th element and it should go up to the pivot minus 1 element. We will talk about it later. If I reaches pivot minus 1 at any position, if the pivot is, if I reaches at pivot minus 1, I will tell you what to do. For now, we are just comparing A of I and A of pivot. A of I is nothing but 3 and A of pivot is 5. Our array A. Now compare A of pivot and A of I. The first condition is if A of I is less than A of pivot, you need to just do one thing, a simple step, I plus plus. That's all. Again, compare A of I and A of pivot. This time you have a different scenario. A of I is greater than A of pivot. When this is happening, the first step you need to do is swap A of P minus 1 and A of P, in the sense our pivot. Swap A of pivot minus 1 and A of pivot. Let's do it. The positions are being swapped. Still the pivot lies here. We have changed the elements, swapped the elements. Now the next step is P is equal to, that means the pivot is equal to pivot minus 1. Here pivot is equal to pivot minus 1. Still it is hanging with the element 5. Now the next thing is swap A of I and A of pivot plus 1. Because pivot is here, swap A of I and A of pivot plus 1. Right? Shall we swap it? We keep I here. We are just swapping these two. Right. So look here. The 5 is smaller than 7, and almost all by now you might be recognizing that the largest elements are coming to the left side of the pivot and the smallest element should be remaining with the right side. And after exchanging this, the last thing that you need to do is I plus plus. Right. Follow the same step again. Compare A of I and A of pivot. And our condition is if A of I is greater than A of pivot, swap A of pivot minus 1 and A of pivot. So where is A of pivot? Here. Swap these two, the pivot minus 1 and pivot. So you are swapping it. Still the pivot is at this particular position. The next step that you do is pivot is equal to pivot minus 1. So it comes again to 5. It's still hanging with it. Now swap A of I and A of pivot plus 1. This is pivot and this is A of pivot plus 1. Swap A of pivot, A of I with A of pivot plus 1. So swap it now. Just we swap it. It's pushing away and it comes here. The I is still here. And the next step that you need to do is I plus plus. I comes here. Now I told you earlier that I will be telling you something that if I comes to pivot minus 1, what to do? If I comes to pivot minus 1, the first thing that you need to do is compare these two. When you compare A of I and A of pivot, if A of I is less than A of pivot, simply swap A of I and A of pivot and go to the step 5. I will tell you what is step 5. Simply swap A of I and A of pivot. So there is no need for you to consider now pivot etc. After you come to this step, you stop here and now you will try to divide the array. How you will divide the array? The 5 is already in its own position. You observe that the 5 is already in its own position. So eliminate 5 here. Eliminate in the sense you don't need to consider 5. How you divide the array? Because the pivot lies at 5 and 5 is separated here. Now the left side of the pivot, that means the finalized element 5 is greater than 5, and the right side of the pivot 5 is less than 5. I hope you understand. The next step that you do is I take J and I because I am getting 2 arrays now. Repeat the same steps again. So if you consider this particular one as one array with 3 elements, this one as another array with 3 elements. Now our 0th element, repeat the same steps for all. So for this array, my pivot will be adjusted to the last element as I said earlier, and my I will be with the 0th element. And for this also, the pivot will be at the last and the J will be with the 0th element. 0th element in the sense, it's your own logic how you divide the array. In my sense, I don't divide the array actually. I use recursion to subdivide the array. So I will say from 0 to pivot minus 1 is one array, and pivot plus 1 to the last element is one array. And now I remove pivot there and I assign pivots to subarrays now. So you are dividing it and conquering at the same time. That's why I say it's log n log n, the n number of elements, and in the number of levels that you are considering gives you log n. I will explain you in the merge sort how this actually comes. Now again follow the same steps. Of course the computer will do it in parallel using recursion, but we will now decide it in a one by one manner. Coming to this particular array, let us consider the same thing. Compare A of I and A of pivot. If A of I is less than A of pivot, you simply do is I plus plus. Now, again, considering these two things, compare A of I and A of pivot. If A of I is less than A of pivot, you swap it. But here in this case, A of I is not, I'm sorry for what I'm saying. So in this case, you don't swap it, as the 4 is in the correct position. So you simply say that the 4 is in the correct position. The pivot is there. The pivot is the last element itself. And you have only remaining things is 3, 2 in one array and 7, 8, 6, 8. Now we will conquer this one. Let us compare these two. If A of j is less than A of pivot, we just simply increase j plus plus according to our algorithm. But here, because A of j is greater than A of pivot, we do swap A of pivot minus 1 and A of pivot. Okay, swap it. And of course the next step is P is equal to P minus 1. So our pivot comes from here to here. Next we do is swap A of I and A of pivot plus 1. So we swap them like this, because this position is pivot plus 1 and this is j's position, because in this array our I is j. The next one is j plus plus. So if it is j plus plus, when j is coming here, j is equal to pivot minus 1, and because A of j is less than A of pivot, there is no need to exchange or swap. They are simply in the same position. So 7 is in the same position and 6 is in the same position, because when 7 comes as pivot, we have said that the 7 is in the correct position here, and remaining two things are single elements. There are no arrays. They will also be considered as part of your correct positions. The remaining thing that we have is these two things. In this particular position, because A of I is greater than A of pivot, earlier I said when it is less, you need to swap at the start of this particular swapping, but it's wrong. But when you need to swap is if a of I is greater than a of pivot, you just simply swap them. And because the pivot is here, it is the element that is good in the position, and the remaining element should also be considered as the correct element. And this is how we do a divide and conquer and quick sort. Thank you very much.